Part 2 of Math 138, Test 1. Problem 5. Find and simplify the derivatives of the following functions. Note, do not use chain rule if you know it. If you don't know the chain rule, then there is no risk that you will use it, so just ignore this comment. Part A. F of x is equal to 2x to the fifth minus 3x plus 90. So the derivative is 10x to the fourth minus 3. You bring the 5 down, combines with the 2, and then the derivative of 3x is 3. The derivative of 90 is 0. B. G of x is equal to 4 square root of x minus 5e to the x plus 2 over 3x squared. So you can't find the derivative of this function in this form. You have to get rid of that square root over here, and you have to move x squared to the numerator. So you have 4x to the 1/2 minus 5e to the x, that doesn't change, and then 2/3 x to the negative second. So the derivative of this function is going to be 2, 1/2 comes down, x to the negative 1/2, subtract 1 from the exponent, the derivative of e to the x is e to the x, and minus 4/3 x to the negative third, because if negative 2 comes down, combines with 2/3, you get negative 4/3, and then subtract 1, you have negative 2 minus 1 is negative 3. C, h of x is 2x minus 1 times x cubed. Now, you could either use the product rule on this function, or you could have simplified it first. So if you distribute x cubed over these two terms, you get 2x to the fourth minus x cubed, and now you find the derivative of this function. So you have 8x cubed minus 3x squared is h prime of x. Or if you use the product rule, that would be the derivative of 2x minus 1 is 2. You multiply it by x cubed, plus the derivative of x cubed is 3x squared, and you multiply it by the first function, which is 2x minus 1, and then you distribute 3x squared over these two terms. You simplify and you get the same thing. Part D. Function m of x is 3x squared minus 4 divided by 2x. You can either simplify this function first, so you can split that into two fractions and then simplify each. You get 3/2 x minus 2x to the negative 1, and then you find the derivative. So it's going to be 3/2. The derivative of m of x is 3/2 plus 2, positive 2, x to the negative 2, because if the negative 1 comes down, combines with negative 2, you get plus 2. And then negative 1 minus 1 is negative 2. Or if you use the quotient rule, so if you didn't simplify this function, then the derivative would be, the denominator is of course 4x squared, because you square the denominator, the old denominator, and the numerator is, the derivative of the numerator is 6x. You multiply it by the denominator, which is 2x, minus the derivative of the denominator is 2, multiplied by the numerator 3x squared minus 4, and then you simplify. You could have left your answer as 6x squared plus 8 over 4x squared. That's acceptable. Or if you simplified it further, it comes down to 3/2 plus 2x to the negative 2, which is the same as the other one. The next problem, just scroll this down. E. The function is y equals 2x to the fifth over 3x plus 1. You have no choice, you have to use the quotient rule. So the derivative of y is going to be 10x to the fourth, because that's the derivative of the numerator, times the denominator, minus the derivative of the denominator, which is 3, times the numerator, 2x to the fifth, and you divide it by the old denominator squared. And then you simplify the numerator, so you distribute, you multiply, and you get 24x to the fifth plus 10x to the fourth over 3x plus 1 squared, and that's equal to the derivative of y. Then function k of x is x squared times e to the x. You have no choice, you have to use the product rule. So the first function is x squared, the second one is e to the x. The derivative of function k is 2x, which is the derivative of x squared, times e to the x, plus the derivative of e to the x is e to the x times x squared. This is pretty much simplified. You just write it as 2x e to the x plus x squared plus e to the x. But if you wanted to factor write your answer in factored form, then you can factor e to the x or x e to the x. So all three of these answers were acceptable. Problem 6. For what values of x does the graph of g of x is equal to 2x cubed minus 6x squared plus 1 have horizontal tangent lines? So we have to find x for which g prime of x is equal to 0, because horizontal tangent line has a slope equal to 0, and the slope of the tangent line is the derivative of our original function. So you find the derivative of your function, which is 6x squared minus 12x, so the derivative of 1 is 0, and you set that derivative equal to 0 to find the points. And you have x equals 0, x equals 2. Now I don't need to find the y coordinates because the problem asks me for what values of x. So I'm just wondering about x's, not y's. Problem 7. Find the domain of each function. Part A, f of x is 2x squared plus 1 over 3x squared minus 12x. So the denominator cannot be equal to 0. I said 3x squared minus 12x not equal to 0, and I just solved this equation. So I factored it and set x equal to 0, not equal to 0, x minus 4 not equal to 0. So I got, I should have crossed this out. You could have written your domain as x not equal to 0, x not equal to 4. There's a mistake here. It should be not equal to 4. Or you could have written it as x belongs to the set of all real numbers except the set containing 0 and 4, or in interval notation, x belongs to the interval from negative infinity to 0, union from 0 to 4, union from 4 to infinity, with parentheses everywhere, no brackets. Part B, function g of x is x plus the square root of x minus 3. So I don't care about what this x outside is. It could be any real number, but we have to make sure that whatever is under the square root is positive or equal to 0. So x minus 3 is greater than or equal to 0, and x is greater than or equal to 3. That's your domain. You could have written it like this, or in interval notation, x belongs to the interval from 3 including 3, so you have to put bracket here, to infinity, parentheses. Now the next problem, oh, it's the wrong file. Problem 8. A rock is thrown upward. Its height in feet t seconds later is given by h of t is equal to 60 times t minus 16 times t squared. Part A. Find the average velocity of the rock over the time interval from 1/2 to 1. So the average velocity is the difference in height divided by the difference in time. So it's h of 1/2, 1/2 being the beginning of the interval, minus h of 1 divided by 1/2 minus 1. Or you could have switched them, so h of 1 minus h of 1/2 divided by 1 minus 1/2. Really doesn't matter which one you use, you get the same answer. So I calculate h of 1/2 and h of 1, and I did that over here on the side. So h of 1 becomes 60 minus 16, which is 44. I just replace t in my original function with 1. So that's what I have here, h of 1. So I'm using this formula, 44. And then h of 1/2, replace t in your function with 1/2, and you get 26. So that's what I put here instead of h of 1/2. Yeah, so I get 44 minus 26, and then the difference between 1 and 1/2 is 1/2. So 44 minus 26 is 18, multiplied by 2, because you have to flip it, and you get 36 feet per second. Part B, find the instantaneous velocity of the rock at time t is equal to 2 seconds. Instantaneous velocity is the same as the derivative. So you find the derivative of your function h, which is 60 times minus 32t, or you can use the definition, which of course would take longer, but you should get the same answer. And then you replace t with 2, because that's the point at which we're finding the derivative, and you get -4 and the units feet per second. And the last part, find the acceleration of the rock at time t seconds. So the acceleration is the derivative of the velocity, which is technically the second derivative of height, so you just take your velocity function and find the derivative of it, which is negative 32 feet per second squared. And that's the acceleration at time t seconds. Even if it was at some given time, let's say 2 seconds, you have no way of replacing it t with 2, so you just leave it as negative 32. Problem 9, the extra credit problem. Find the following limit. And the limit is as x approaches 3 from the left of x times the absolute value of x squared minus 9 divided by 2x minus 6. Now, if you just replace x with 3, you won't get anywhere because you get 0 over 0. So you have to simplify it somehow. Now, as x approaches 3 from the left, x squared minus 9 itself, I have an explanation here. So as x approaches 3 from the left, x is smaller than 3, so x squared minus 9 is smaller than 0. Therefore, the absolute value of x squared minus 9, now x squared minus 9 is a negative number. Now, if you have an absolute value of a negative number, then you have to force it to become positive. And how do you force a negative number to become positive? You just put an additional negative in front of the whole number. So if x squared minus 9 is a negative expression, then I destroy that negative by multiplying it by negative 1. As per the definition of the absolute value. The absolute value of a is negative a for a smaller than 0. So my absolute value in the original function changes into negative times x squared minus 9. And that's what I have here, negative and x squared minus 9 without the absolute value. And now, once the absolute value is gone, I proceed as in the other problem. So I factor the numerator and the denominator, simplify x minus 3, and then replace all x's with 3, and I get negative 27.